Welcome to the Ecotechie. In today's video, we are going to look at an economic concept. But before we start with the economic concept, let's do a simple thought experiment. Let's assume that we are an individual. We are rational human beings. It means that we aim to maximize our utility. And we only have 50 rupees in our hand. Using this 50 rupees, we can either buy samosas, which cost rupees 5, or we can buy vada pav, which cost rupees 4. Now, the classic dilemma which is in front of us is how to divide this 50 rupees between vada pavs and samosas so that it can maximize my utility. To resolve this issue, Professor Alfred Marshall came up with the classic law, the law of equi marginal utility. The simple law states that in order to understand how to divide the rupee 50 between vada pav and samosas, we have to see to it that the marginal utility derived from samosa per rupee should be equivalent to the marginal utility derived from vada pav per rupee, and both of these should be equivalent to the marginal utility of money. Now let us look at a table. So in this table, we have the marginal utility for samosas and we have the marginal utility for vada pavs. And we know that for equimarginal utility, we are going to equate the marginal utility per rupee for samosas and marginal utility per rupee for vada pav. So we are going to divide the marginal utility of samosa with the price of samosa, which is nothing but 5. So when you divide 50 by 5, you get 10. Similarly, when you divide 36 by 4, that is the price of vada pav, we get 9 over here. Now, over here, we cannot have an equation between these two columns. So, we drop this combination. The next combination we have is of 9 over here and 9 over here. So, you have a combination of 2 samosas and 1 vada pav. So 2 samosas cost 2 into 5, which is nothing but 10, and 1 vada pav costs 4. So it is nothing but 10 plus 4, which is 14 rupees. Now the income in our hand is 50. So we also have more income in our hand. So we can aim for a higher indifference curve. We can aim for a higher utility by buying more of the goods. So you check for the next combination. That is 3 samosas and 2 vada pavs. 3 into 5, 15 plus 2 into 4, 8. 15 plus 8, which is nothing but 23. Again, you are not exhausting your income. You will only exhaust your income when you reach this point where you take a combination of 6 samosas and 5 vada pavs. So 6 samosas cost 6 into 5, which is nothing but 30, and 5 vada pavs cost 5 into 4, which is 20. So 30 plus 20 is 50, and 50 is the maximum amount which we have in our hand. So we will choose 6 samosas and 5 vada pavs. How have we come up to this position? By equating marginal utility of x upon price of x and marginal utility of y and price of y. And finally, we have to equate this to the marginal utility of money. Since this is an economic theory, let us assume that the marginal utility of money is also given as 5. So when we have 6 samosas and 5 vada pavs, we are reaching the equimarginal utility between both samosas and vada pavs and the income that we have in our hand. So this was the numerical explanation and why we went on increasing the combination of vada pavs and samosas till we exhausted all our income. Now let us look at this graphically. Now we have our x-axis which measures the quantity of good, and we have the y-axis which measures the marginal utility of money or expenditure. That is the marginal utility derived for a samosa for a rupee. So this is our marginal utility for vada pav per rupee. It's a downward sloping curve since we know that as we increase the amount of vada pavs consumed, definitely the marginal utility derived from it is going to fall. Similarly, we have the marginal utility for samosas given by the downward sloping red line. Over here, we assume that the marginal utility of money is constant. Let us call it M of M. So, we have the optimal combination, that is, we are going to consume Y units of vada pavs and X units of samosas, where your marginal utility per rupee for samosa is equivalent to the marginal utility per rupee for vada pav, and marginal utility of money is equal. Finally, if there is an increase in an income, suppose our income has increased from 50 rupees to 60 rupees. Hence, the marginal utility derived from 60 rupees is going to be lesser than the marginal utility derived from 50 rupees. So, our curve is shifted downwards. And when it shifts downward, we go on to consume more of vada pavs and more of samosas. So over here, we are able to graphically explain the principle of equimarginal utility. Now to conclude, let us look at the actual lines given by Professor Alfred Marshall. According to Professor Alfred Marshall, if a person has a thing which can be put to several uses, he will distribute it among these uses in such a way that it has the same utility in all. Finally, just to wrap up the entire thought experiment, so we are going to be at the maximum utility when the marginal utility for samosa per rupee is equivalent to the marginal utility for a vada pav per rupee, and it is equal to the marginal utility of 50 rupees. I hope the idea of law of equimarginal utility is clear for one and all. Thank you. Do like, share and subscribe to the Ecotechie. If you have any doubts, kindly post it in the comment section below. Thanks for watching.